This is a video of the follow-up of my last weekend DIY project. My home heater, the furnace, have the not fire up issue, and I have to replace the flame sensor, and eventually I have to also replace the controller. And now the furnace is totally fixed. During this project, I have gone through the major part and major controller of the home furnace. Actually, there is some of the experience I can share in this project to the viewer. If you have the same situation happen in your home, you might be able to put your hand on that to make an emergency fix for that. I'm not an expert of this home heater or AC, but actually if you have some kind of basic electronic knowledge and some handy skill, you don't even need a lot of tools to be able to work on the furnace. There is a majority of those parts are very easy to access, and if you can identify which part is have problem, you can maybe just order the part and replace them. I will believe majority of the part, if you're doing right, it's pretty safe. Sure, safe will be first. Before we can do anything on any equipment or any of the unit, we have to understand how it works and what is the part we'll be able to safely replace it or fix it, and what is the part we have to call the professional to be very careful to be able to fix it correctly. First of all, this is a gas furnace, and this part, this is the gas come from the gas provider, and come in here. There is a valve. This is a manual valve. We can use it to turn on and shut off the gas from the outside to the unit. With this valve turn on and turn off, we can service the unit without make the gas leaking. After the gas flow into here, and this unit is a gas valve. This is one controlled by the controller over here. So the controller can get the signal from the home temperature setting and control the valve over here to control the gas flow from here going down and push into the burner. And we can see it quite a bit path on the valve. Right? It has something called a menu shut off or electronic control, all kind of stuff, and connector. And if this valve have problem, if this valve have the issue, have to replace or have to diagnose it, I would suggest you hire professional people to do that, because anytime when you touch this thing over here, or even the seal over there, has to be airtight. if you got something wrong, and you will have the gas leaking issue in the home. And if this leaking is very slow and very small, then even worse. You don't even know you have gas leaking. You might cause like a big issue, big problem for that. Also, some people also mention, say, if you service the valve, you better also replace this valve at the same time. I'm not sure that's true, but if you can replace this valve, you have to call the gas company to shut off the valve from outside, and then you can replace this one, and you can work with it at the same time. So if you get this both replaced, it might last much longer than you only replace this valve. After the gas provider, that section, we come to the air security section. You see, there is a filter in here. In my home unit, this one is Honeywell. It used to be not using this kind of a filter. It is electronic filter here, but I will replace it just using a normal filter. So this is the filter over here, and the air, intake air, come from here. Yeah, let me pull it out. The ductwork from the top, the ductwork, and the ductwork, the air come here and circulate through the filter. The filter here is filter out like the dirt or the particle, anything is trapped in the filter. And there is a motor down here, a motor. This is a big motor. There is a capacitor for the motor, and this is the most easy have problem part. If you have the motor is not working, this part maybe the first one you need to take a look on that. So if the air comes through the ductwork, through the filter, and get into here, because when this motor spinning, it's a high-speed motor, the air going to be sucked up from here, go up through here, go up through here, and go to the like this outlet ductor, right? So the air, it doesn't matter it's hot air or cold air. It comes from here, runs through the motor, and goes through the burner heat exchanger here. So there is a, you see, the air conditioner AC have the AC. They have a condenser here, over here, inside here. So it doesn't matter hot air or cold air. It runs through the same path, goes from here, go into your home, and the ductwork over there, the ductwork on the top, gonna split the air to your different room and different section of your house. And the airflow is for the hot air or cold air. There is another air. We need to be very careful of that. So as we know, the gas come in from here, the valve, and this is the burner. This is the burner. When the air get into the burner, it's gonna burn inside it. When the gas burn, it's gonna create oxygen, carbon dioxide, and that air gonna going up over here, and there is a vent over here. This is a vent. This is a fan. There's a fan over here. This is the fan who suck up the burned air and runs through this outlet. You see there is a pipe over here. This is a pipe, and this pipe go up to over here, and then you go up to the chimney. This is connected to the chimney outdoor. This is the thing you can see on the top of your house. It's a chimney. Actually, the basic unit is over here. Air, the gas come in from this hole, and it just gone through into this burner. The burner inside is burning the gas, and it's not very different from our oven when we do the cooking, and it's not very different to that. Same thing as the gas get into here. There is igniter here. Igniter. The igniter inside, it just got burning hot. Then ignite the gas, and it's burning inside here to make the heat. So its basic function is the same as our gas oven or gas stove. But because this unit, most of the time, nobody will here to monitor that or watch it, and it can run 24 hours a day, and like 355 days a year. So the most part in the unit is controlled safety. It's a safety function controller. Okay, let's talk about how the unit is working by the temperature control. We all know we have a control panel. Usually it's in the main floor. You have either the old style or the modern. Right now I see some family that have some kind of the Bluetooth control, that kind of controller. It doesn't matter what. The controller over there, let's talk about the heater, not the air conditioner. If we control the heater, for instance, you set the temperature is 70 degrees, then if the room temperature drop to 70 degrees minus 2 degrees, usually it's 2 degrees, minus 2 degrees, let's say the temperature dropped to 68 degrees, and the control panel will send a signal to the the furnace. It's over here. Over here, the control, the connection is from this wire connect to the upflow. So this kind of, you see, this is the wire from the top floor. Now, if you get the signal from here, and then this one will through this wire to here to control this unit. And once this unit senses the command from the control panel to kick in the heater, then it's gonna have a sequence of the command with some sort of the timer, and detect some of the sensor return signal, and then make the whole thing work. So what is the sequence of the controller will do for the whole unit? The first thing, it will turn on this fan. This fan is the most important. If this fan is not on, then if you have anything into this chamber, inside that, if this fan is not on, so this kind of, it doesn't matter, gas or the film or anything inside, it can leak to outside. And leak to outside, you're gonna get into your living area. Sometimes it's very poison like a carbon dioxide. Sometimes it's very dangerous, like if you have the gas leaking. So this fan will be the most important part. Has to be turned on before everything to work. But how the controller know the fan is work? The controller is not detect the fan is spinning or the fan have take any current or something. Actually, the controller using this valve. This is something called what? Pressure valve. Using this valve over here, there is a connector. Connect to inside. Is that this thing has to be airtight. This has to be airtight, and this valve actually is something like a vacuum valve. A vacuum valve. The theory is very simple. Once this fan runs, right, and it can suck up the air from here and blow it to the up chimney. So once this thing suck up the air, so the pressure underneath this chamber will be lower than outside. So when this thing lower than outside, there is a vacuum through this pipe, get to this valve. And when this vacuum trigger this valve, and inside this valve they have a default open switch. Default open means if you don't do anything for them, these two wires, they are open. They don't connect each other together. So once you have vacuum from here, these two things will connect inside. So this thing called pressure valve. So once you have the fan run, you have vacuum through this thing, and these two things will connect it. Once they connect it, it sends the signal from here to the controller. And the controller know if the vacuum exists. That means it's safety to give the gas or burner something. If something happens in this section, the fan can suck it up from here, right, to the outdoor. It can be a little bit safe. Then you don't do anything. And if this fan is not working and something gonna leak from here or from inside, get out from to the living area, that can be a major danger for the family living in the home. After the fan run and the vacuum sensor detect vacuum here, and controller will start to provide the signal to the valve over here, to the this is gas valve. You can send the signal to the gas valve. This is the electronic relay. It's a valve control the gas to flow from here to the burner. So you're going to trigger the valve. Once the valve is triggered, gas is provided from here to get into here, right? Get into here. So this is the major function to the burner start to work. But before the controller provide the gas to the burner, like you are using your oven, usually you need to turn on the oven, right? If you turn on the oven, you see the spark, tuck, 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 try to light up the gas. And in over here, usually they use something called what? Use igniter inside here. Inside here, this is igniter control wire. See that? And connect to here. What is an igniter look like? This is igniter. Yeah, I got two spare over here. See that igniter over here? This is igniter. They have a connector with 2 wire. And see this thing, right? Actually it is connected each other here. It's connected like it's make a use an M shape, an M shape here. See that, an M shape. This thing in the electronica we can say is just a resistor. It's a resistor. The resistance over here, when you provide a circuit into here, and resistor times the square of the current, it can be the power of this unit, and it can be generally like heat. So this thing will burn like red, hot, very very high temperature. It is similar to fire. Then with this thing on, it can stay about 15 seconds. Some unit they use a slower heater, a slower igniter. They have 45 seconds. So there is 2 different type of the igniter, and 2 different type igniter work with different type of the control unit, Yeah, I always introduce the different serial number on the unit to identify which unit is using for the 45, which unit is used for the 15. So if the igniter down here inside is burning like a red hot, after about 4 or 5 seconds, the controller will release the gas from here, natural gas, into here. Because the fan is building up a vacuum inside the chamber, so this pipe, these 2 pipes, it suck up the gas from here. If you don't have the vacuum, the gas is gonna leak from here to outside, But because the vacuum, when we see the burner actually have a gap over here, right? Have a gap. It's totally open here. So the gas will get sucked up into here, and then it can burn inside. It can burn inside because igniter is over here. It can ignite the gas, and the gas will burn. And once the gas burns, it generates a lot of heat, and the heat inside over here, inside inside the chamber, there's something called what? Called a heat exchanger inside. So it's a heat exchanger inside. If that thing have problem, you definitely need to call a professional. Don't do it yourself. And also that thing is, I believe, if once that thing have problem, the whole unit maybe just totally get rid and reinstall the new one. So once the gas burning from here, the fire heat up the air. It comes through the heat exchanger here. The heat exchanger make the burning air isolate to the circular air. So we should remember this air is not getting into this circular. It's not getting into here. It cannot be get into here because carbon dioxide. So the heat exchanger has to be inside to be not cracked, not leaking, not anything. They only have that thing burn very hot, and when the air from here up to here pass through the heat exchanger, it just gets heat up. The air gets heat up, and then pass through here to get to the up level. The burning air, the air who get burning actually come to here and through this fan and get into this, get out from here, and get all the way to the chimney. Right? So definitely this is something different than the oven we are using for cooking. When we cook something, the fire, we can see the fire is in the room. But because we are sitting there, we are watching when we are cooking, and we might not totally seal our window, our door, and maybe a lot of family we have air circulate, that kind of called what, fan to suck up the burning air to outside. So the oven, the basic unit is the same thing: burning air, burning gas, but the oven is release the burning air into the living area. But this furnace never and should not release any burning air to the living area. So what situation can cause the burning air to leak to the living area? Sure, we already know first one is this fan, right? This fan has to be run. This fan has to be built up vacuum inside the chamber. And this vacuum will detect by this pressure switch. So with this one working, and we know this fan is working, and this fan will suck up the burning air from here. Okay, this for the burning air. The second thing is what? The circular air. The air actually come from here, go up, to up, up to here. And this circular air had to be good. They had to be running. They had to be have air pressure to push the air to the car. What kind of situation can cause this air is not circular? There's multiple reasons. Most stupid reason we can see, and you can check some of the professional service people complain about that. People don't change their air filter. They don't change the air filter. Let's see what is air filter look like. This is a very typical air filter. My home, they're using the electronic air filter. Before I switched to just use the normal filter. So I have a thicker filter. Most of the family, they have just 1-inch filter. It's a small filter. Make sure the size of your filter is fit your furnace before you buy that. A filter is very simple. It's just some sort of the material over here. When the air flows through here, and the particle or the dirty dirt will be trapped inside this filter. So only the air pass through the filter, but filter itself, it traps the dirty stuff over here. So it depends if you live in an area very a lot of dirt or a lot of particle flow in the air, and then you will have this thing clog, a lot of thing build up on the top. If you leave this thing for years, not change it, and it's very dirty, so when this thing's dirty, so the hole inside the filter got like a seal, so the air won't be able to pass through that. Without the air pass through that, so the air will not be able to circulate to the house. So this thing can actually block the air from the inlet to the outlet. So this is the most easy fix, or most thing. All we can say, first thing we needed to do for our maintenance work. Also, based on the filter, there is a couple of the knowledge we need to know. First thing is there is error over here. There's an error over here. What this mean? It's not important for the normal use. Air can go through this side to this side, or can go through this side to the other side. But that's different here is what? The filter, see this side? It's wide open. There's no mess over here. Go by this side. See, there's metal mess over here. The metal. What this mean? This mean is if you don't change this filter for a long time, all this thing broken, and the vacuum power from the fan will suck this material into the fan. They suck this into the fan. But because this metal over here, they are connected to the container, so it blocks this material. Anything broken to fly into the fan or fly into the outlet. But turn to this side. There's no metal here. So if you got this thing broken, and this thing can just fly into the fan to make a damage. Maybe sometimes this damage is very severe because what? It can clog your fan, and then if the fan get clogged, the overcurrent, it's gonna be bent up, and you have to replace the fan. So be careful. If you do replace this, pay a little bit attention to that, to this. And also there is another parameter is what? If you say I will find a very cheap filter, the cheap filter, it have more air can pass through here, and then you get some of the dirt or particle run through that. If your home people have very sensitive allergy, then you might have some problem. But if you say, oh, I'm gonna buy a very thick, very fine, that kind of filter, yeah, sure, you can trap a lot of like dirt or everything, or even trap everything, or even I put a two layer of the filter, and it's okay for trap the dirt. But the problem is what? If you put two layer or very thick filter, the air flow through the filter gonna be slow. So your heater or your air conditioner, the efficiency will be drop, maybe drop a lot. So by that kind of a situation, if the normal family, we just suggestion pick the medium layer will be okay. Don't put the very aggressive stuff. Okay, now how the controller to prevent the people don't change the filter and something happen when the lower, let's see, something happened to the fan, lower fan, the main fan down here is broken. If the fan is not running, if the fan is clogged, or the fan have some electronic issue, it just run not efficient, run slow, something like that, how the controller can prevent this kind of issue happen? There is something we can identify in the chamber, inside the chamber, right? If this filter is clogged, or if this fan is not running, or running very not efficient, running very slow, so the air inside this chamber will flow very slow, will be slow, right? When the air runs slow inside, but the burner keep providing the heat into this burner, right? Into this chamber, then the temperature over here will be very high. It's gonna build up, right? So there is one other controller over here. This is something called overflow limited or something like that. It's a limited controller. So this controller have 3 settings. This controller is a little bit complicated. It has 3 settings inside. One is the lower setting. The other one is a higher setting, and then there is a cut-off setting over here. There's 3 settings. I'm not going to get into that detail about the setting, how to set it up, or how this thing works. That base knowledge is what? This is the start to detect inside temperature. If the inside temperature is not met the requirement of this unit, then it sends the signal to the controller. Cut everything off. Cut everything off. So this is the unit. Actually, it is the for the safety of the circulate air. So this one controls the air circulate from the inlet to the outlet to detect the temperature inside, to allow the burner keep burning, or allow the burner or cut off the burner. There is one switch here. Some home have the unit with a switch here. If this thing is overheat and cut off the air, cut off the gas, it doesn't work. It stops the unit to work. You need to come over here to switch this thing, to manually push the switch to let the unit work again. Some is defined for reset after the thing cool down for some time. But be careful. Once you have this thing happen, cut off your unit, don't just come over here to switch that thing on. If you switch that thing on, sometime you didn't find the cause, and you might get that thing kill your gas again. It can stop working again. Or the worst scenario, because this thing actually works as it's supposed to work, like your fan or your filter or your whatever, the ductwork have problem, you need to fix that before you reset this thing. If you just go there, keep reset that thing, you're gonna have overheat inside your chamber, and you're gonna have the poison air come into your living area. That is not the thing we want. There is another controller over here we needed to introduce. There's one thing over here. See that thing? This thing used to be, they have 2 connections to connect to the sensor. There's one small stop over down here. One small stop, maybe a sensor. What this thing doing? This thing is called gas overflow detector. So somehow, if this gas is supposed to be get sucked up into that and burning inside there, nothing gonna come out from here. If the fire is burning over here, then you get big problem. So this sensor is over here to detect if any gas, the fire overflow to outside. What can cause that thing? What can cause that thing? Either the exhaust fan is stop working, or some sort of the air come from outside to push into the inlet, push into the outlet ductwork to make a lot of push from down there, from the top push. See, if you have very big air pressure from outside to push the air against your fan to come back down here, then you're gonna blow your fire out here. When the fire is out here, it triggers this thing, and this thing gonna send a sensor to the controller. The control gonna kill the gas valve over here. It's gonna stop the valve. So that flame overflow or something, I forget the exact name of it. So they protect the flame to come out from the burner it's supposed to be in. Oh, I almost forget one of the most important sensor in this furnace. It's the flame control flame detect sensor over here. It look like it. See that? It's very simple stuff. The outside metal connector is mount the stuff to the metal case, and this is the sensor. I think I don't know if it's positive and negative lead, but actually it's two lead over here, right? So once the fire burning this body, it doesn't matter the tip or the body, and this thing gonna send a signal to the controller. Say, oh, I see the fire. I see the fire. When I see the fire, that mean what? That mean the burner inside, the gas is burning. But somehow, if some problem caused the gas provide into that, but there is no fire inside, so the gas is gonna keep coming in, and it may cause the gas leak to the outside, or the minimum situation is what you just push the gas and then it can blow up to the chimney on the top. It doesn't do anything, right? So this flame sensor is the most important. Detect the fire is on. If the sensor see this guy in 4 to 5 seconds, does not give a signal back to the controller, cut off the gas. And I watched one of the video for a professional people who he did service for many years. So he rated 10 most problem in the furnace, and this guy is the first one. This is the first one who caused the furnace stop working. And basically, to replace this thing is very simple. Just one screw over here and one connection from here. Anybody can do that. But majority of this controller is not because it's just broken or something. It just got dirty. Something built up on the surface. You see, for mine, there is some. You see on the tip over here. It actually have some problem here, right? And then you can just use some of the. Somebody say use a $50 bill and $100 bill to clean up this sensor. And definitely, people's suggestion you don't use the sandpaper to clean it up. Don't use sandpaper. Don't use something can damage the surface. You can use like printer paper, or you can use some of the dish cleaner, that kind of a little bit can clean up things but not scratch the surface, that kind of material to clean it up. After you clean it up, if you look intake and then you put it into there, try that. And I believe this thing's supposed to be serviced at least every couple years. I did make a service for my own unit couple times, but this time when I clean it, it's just broken. I lost the tip about a 1/4 inch, Uh, First thing I always do is, I don't care what is the problem for the unit. This one has to be replaced. So I order another one to replace that. After I replace that, and my unit is still not working, the controller provides the gas to the burner for only 1 second, immediate shut off. But if I trigger 2 or 3 times, like I turn off the switch, turn on the switch, turn off the switch, turn on the switch, 2 or 3 times, oh, it stays. But in the night time, nobody there, and yeah, the controller gonna make a 2 try to the start it. But after 2 try, it fail. It just sit there. It just sit there, blow the cold air. Only the exhaust fan is running, and the other thing is not running. So that's my problem since last week. So I replaced the sensor. It's still not working, and eventually I have to replace this controller. I got this controller yesterday and replaced it. Everything fine. It is a used controller. I believe this thing is 30 years or 40 years old out there, and I got that thing about $50, and take my 10 minutes to put it in, and it worked. Now the whole thing is to work as expected. Let me demo to you how I identify my unit is not burning gas. It's because the controller is not the flame sensor. Even though I would replace the flame sensor, it is required because it's old and broken, but it doesn't finally fix the issue. So now let me demo how do I identify that. First of all, you see my door connector is open, so I have to put this door panel back to there to properly close the door. After I close the door, so the switch over here is contact, and the power gonna provide to the unit. And one other thing, we will identify the circle of the unit, how they control the work. First of all, my switch is off over there. You see my switch is off, and right now I set the temperature is much higher than my room temperature. On the top, you see this wire. This is the signal wire from the control panel to here. I set my temperature higher than my room temperature. So if I turn on the switch, power switch, it's supposed to be kick in the signal to this controller. And this controller, first of all, it's gonna turn on the fan over there. The fan gonna run. After the fan run, and then you're gonna have the vacuum from that vacuum sensor to detect the vacuum in this wire and this tube, and then send the signal to the controller. And the controller detect the fan is on, right? And also sure, this controller is initial. It have nothing. It have no problem at all because there's no temperature higher inside. So this sensor gonna start to send this power to this thing. You see behind here, to this thing, right? This is the same over here. This is the igniter. So once this detect everything good, the send current to the igniter down here. Here is the igniter. This thing, right? It's this thing. So the igniter gonna be light up, red hot inside there. We can see it later over here. It's red hot. Once that thing trigger up, about 2-3 seconds, and the controller think, okay, now it's ready. So it send the signal to the switch, to let gas run through here, inside here. Because the fan is on, so the gas will suck up into that, and this igniter still red hot, so it can trick up the fire down here. So how to identify it is the igniter issue or the controller issue? Let's do an experiment of the flame sensor fail. What it look like inside the unit. I disconnect the flame sensor. See that? I disconnect it. So now the flame sensor will not have signal sent to the unit controller. So if I turn on the unit, it's gonna turn on the fan, it's gonna turn on the igniter, it's gonna give the gas, and then the igniter gonna burn the gas. But after the gas start to burn, the flame sensor is disconnected. It doesn't send the signal to the controller. Say, I detect the flame. The controller say, no flame, then it shut off the fire. But let's see how long it doesn't last. This unit have 45 seconds before it start to send the gas to the unit. So let's see. Now first thing is the controller turn on the fan. Once the fan turn on, the vacuum sensor will detect the vacuum. After the vacuum detect, it sends a signal to the controller to turn on the igniter. As we said, this thing have like a 45 seconds, I believe, is the delay for the igniter. The igniter down there, you will see, oh yeah, now it sends a signal to igniter. It will be, see, red hot. After a couple seconds, send the gas. 1, 2, 3, 4, 5. See? 5 seconds later, the controller turn off the gas. I bet it's gonna make another second try, but I don't think we need to repeat it right now. Let me connect the flame sensor to that. Now the flame sensor connected. Now if I turn on the switch, the igniter will be on. Gas. Yeah, the flame sensor down there. Let's see, flame sensor, can we see that? It's down there, right, near the fire. So the flame sensor detects the fire and it sends a signal to the controller. Say, I see the fire, so you can keep sending the gas. Yeah, see over there? Yeah, that is the the red hot stuff is the flame sensor, and this is the overflow sensor over here. If the fire come out here, it's gonna suck up the air, and if the air is not circulating, temperature here gonna be very hot, and this guy is gonna cut off the air. And this is exhaust fan. If the exhaust fan broken, there's no vacuum over here, and this guy is gonna shut off everything. So the whole unit is work coordinate each other with this controller. Let's take a look on the model, the controller module. The model number is 50E47-140. Actually, this is not my original controller. My original controller is 50E47-60. It's slightly different from 60 to the 140. The 140 have something called pre-purge. It means before the controller send the gas and ignite the fire, it get a 40-second purge. So the fan will run 40 seconds to clean up the burner and the chamber. After that, it ignites the fire. After this, it's similar to my original unit, and because this is old unit and it's very expensive if you want to buy the original one, the new one, it's a couple $100. I bought this thing from the eBay. It's a used unit. It's about $60, include the shipping. It's okay to use this for the 140 to the 60, but there is some other model have a longer ignite time. Longer ignite time is 40 seconds in ignite time, and that one I think you better find the same model with the same ignite time for the unit. My unit have 15 seconds. The igniter will only last 15 seconds. It won't last 40 seconds. If you have a unit with the 45-second igniter, then you have to find the one with the 45-second igniter, or your igniter will not be hot enough to start a fire. Yeah, I'm working in electronic a lot, so this kind of a circuit is not very secret to me. I will believe if I want to identify what is in this circuit board, these two things and this one, this actually is igniter connector, and this is a relay provide igniter circuit. It has a 10 amp, one of the relay 12 volt 5-pin relay to provide a 10 amp circuit to the igniter. This thing's working fine for my unit. I believe it's good, but there is another one over here. The number is LS-12SC, and this is two stop with a 12 volt control voltage. I believe that is for the gas valve or some other stuff. Based on my knowledge to this circuit board, I'm not saying 100%. I didn't do any electronic testing on that, but based on my experience, got to be one of them. The contact inside have problem. I already put it in order for this tool. I cannot find this one, but I already put it in order to this tool from the Mouser. A couple days later, it can arrive.